Hello. Okay, so let's go into the next question here. So the next question that we are going to talk about is the Poulet question. So for Poulet questions, it can go both ways. If you really get it, it can be quite easy to solve. But if you don't actually see that thing, then it can take quite some time. So today I'm going to try my best. I'm going to try my best, and I'm going to show you some of the methods that I use to solve Poulet questions. And most importantly, how do we have a systematic order of thinking, a systematic idea, a systematic way of thinking to solve this kind of question. So I'm not going to do much explanation. I'm just going to dive straight into the fourth question of tutorial 4, and from that very one from that question itself, we will try and see how do we solve Poulet questions in general. Okay, so let's take a look at question number 4, tutorial 4. So this question says that we have two things. We have two blocks, block A and block B, and they are basically constrained by this Poulet system. So as you know, all Poulet questions is a constrained question, right? So it's, the motion of the A and B is constrained by one thing, which is the length of the string. So how do we solve this question? So first of all, let's just go with what usually we will settle, all right? So but in my perspective, I think we should not start thinking hastily. When we actually encounter a question like this, the very first thing you should do for Poulet question was to find a datum. Find a datum. Please lock this in your mind. Find a datum. So, and measure all your distances, all your parameters from that very particular datum. So in this case, since A and B is only moving to the left and right, my datum will definitely be somewhere on the left or on the right. I can literally choose any datum. As long as my execution is correct, I will get the same answer. However, because the string is all at the right side, so it's easier for me to choose a datum at the right. So in this case, I will choose this line here, this black color line here, this is my datum. So every single measurement of block A and B in terms of their velocity, displacement, acceleration was all measured from this datum. Now, when I do that kind of justification, eventually the next step is basically to implement the constraint equation, right? But to implement a constraint equation, let's take a look at something very interesting. So if I were to implement a constraint equation, I'm definitely going to say that the displacement of A from the datum is RA. The displacement of B from the datum is RB. And if I were to look at this red color thing is the line length. So the length of the whole string is just equals to, this is RB, this is RB, this is RB. So it just equals to 2RB plus RA. And when I differentiate it one more time, I can find the relationship between 2R dot B plus R dot A. Right? And I differentiate one more time, what I get is that 0 is equals to 2R double dot B plus R double dot A. Now, and it is very tempting to say that R dot B is actually the velocity of B, which actually is true in a certain sense, but the direction itself might be of a misconception. So today, my purpose here was to show you a method to make sure that you do not mess up the positive and negative that you were defining. Okay, that's my main purpose here. So basically, if you were to follow the LAMS method and to go on with teachers' lectures, I'm quite sure you can set up this equation. This is very well explained in Prof. Yap's what is it called, LAMS. And you can know that the constraint equation can be set up in this manner. And when differentiating, you get the rate of change of B, rate of change of A, and the double derivative of it with respect to, and equate it to 0. Now, here's the interesting part. What is RA? Now, the truth to be told, this is actually not really the differentiation of the displacement or the differentiation of the velocity, no. It's actually the differentiation of the magnitude of the velocity. What I'm trying to say here, this is purely, it doesn't involve directions inside here. There's nothing involving directions inside here, apart from the case that they can be positive or negative. So it's very hard to see what is actually the direction of B, the direction of A, and what is the supposedly positive direction for A, positive direction of B. Is the direction, is the positive direction of A to the left or to the right? Is the positive direction of B to the left or to the right? How do we know it? So this is the way that we can actually discern whether which direction is positive, so-called positive in this sense. So if we look at it, for A's parameter, the displacement of A is actually equals to RA, direction 180 degrees, right? Because it's just this direction here. And so velocity of A is actually equals to what? It's actually equals to you differentiating this thing. Now, please take a look. When we differentiate this term, 180 is a constant, right? It's not going to change. So what we have is the velocity of A, if we calculate the velocity of A by directly differentiating the first part, which is what we have done here in the constraint equation, we are assuming that the velocity of A is equals to R dot A direction 180. We are also assuming that acceleration of A is equals to R double dot A direction 180. Same thing that goes to B. Now for B, we realize that the displacement of B is equals to RB direction 180 degrees. But the velocity and the acceleration is all, 180. Why is it so? Because we obtain the velocity and acceleration term by directly differentiating the first term. So, in other words, R dot A is only positive if the velocity of A going to the left. R dot B, velocity of B, the R dot B is only positive if the velocity of B is going to the left. But as you can see, this is quite impossible. So let's try to solve this question and see how this goes out, right? So the question says that after 6 seconds, the relative velocity of B with respect to A is 450 millimeter per second. So in other words, velocity, so they are trying to tell us this, okay? Velocity of B with respect to A is equals to 450 after 6 seconds. So this is very interesting. This is very interesting. Why? Because, now take a look at this. Velocity of B with respect to A is 450 millimeter per second. In which direction? Is it to the left or to the right? Now we see from the question it says that column A starts to move to the left with a constant acceleration. If column A moves to the left, and since the length of the string must be conserved, if this pulls here, we can kind of see that B will be pushed to this direction. So in other words, in A perspective, B is always to the right. So we know that this 450 is going in the 0 degrees direction, right? This is very important. So how do we form this velocity of B with respect to A? Now this is actually after 6 seconds. After 6 seconds, when both of them starts from rest, velocity of B with respect to A is 450 degrees. So in other words, we can, from this understanding, we can actually calculate out the acceleration of B with respect to A. Now please take note, first of all, now this is very interesting understanding. Acceleration of A is constant. Acceleration of B is also constant. Why do I know that? Because this is the equation that they are, they are bounded together. The acceleration of A is constant, acceleration of B is constant. But acceleration of A is constant, acceleration of B is constant. According to our previous tutorial, we know that the acceleration of B with respect to A will also be constant, right? When acceleration of B with respect to A will be constant, I can find it by directly integrating this term, differentiating this term. But you say this is actually a constant, how can I differentiate it? Well, I'm going to let you figure this out yourself. Okay, so the hint is actually after 6 seconds, this is the velocity of B with respect to A. In other words, when t equals to 0, velocity of B with respect to A is actually 0. So if we know that after 6 seconds times 6 you get 450, if you divide by 6, 450 divided by 6, you can find out that the acceleration of B with respect to A is actually equals to, let me see, it's actually equals to 75 degrees. And usually it's also 0 degrees, because you do by differentiating this. Now, what is acceleration of B with respect to A? This is actually equals to acceleration of B minus acceleration of A. Right? And you can see it clearly. What is acceleration of B? It's this thing. R double dot B. Direction 180 degrees. Minus what is acceleration of A? R double dot A. Direction 180 degrees. Now, I have to re-explain. Now, I know some of you might be confused. How do I get A, B slash A or 75 from velocity of B slash A 450 millimeter per second? Now, here's how I obtain the solution. First of all, this is the velocity of B with respect to A after 6 seconds. Velocity of B with respect to A when time is 0 is equals to 0. How do we know that? Because when t is 0, time is 0, velocity of A and B are both 0 respectively. You can look for the question. Okay? So, in other words, it means that since I know my acceleration of B with respect to A is a constant, it means that the velocity will increase linearly, right? This is basically your understanding of kinematics. The velocity increase linearly. So it means after 6 seconds, my velocity of B with respect to A is 450. So I divide 450 with 6, I will get acceleration of B with respect to A. Okay? That's what you have to know. Oh, I'm running out of location here. So now, let's see this. So acceleration of B with respect to A is 75, direction 0 degrees, and this is what I have here. R double dot B, direction 180, minus R double dot A, direction 180 degrees. This is the thing I have here. How do I achieve this equation? Firstly, by understanding that AB, AA is plugged directly from this term here, and I got this whole thing here. Okay, so from this equation, please take a look very seriously. 75, 0 degrees. This goes 180 degrees. I cannot directly cancel out the angles because they are different angles. So what I do is that I convert this one into 180. If I convert 0 to 180, it means what? I need to add a negative sign in front, right? I need to add a negative sign in front. Now, since this equation here is all 180 degrees, I can cancel out the 180 and I form one equation, right? And from negative 75 is equals to R double dot B minus R double dot A. Now, so from here, I have two equations that relates R double dot B and A. In other words, I can find R double dot A and R double dot B by doing simultaneous, and I get this part here. And the rest of the equations is actually just very simple kinematics, what is it called, manipulations. Now, but for this question, the main important takeaway was that first of all, we have to set up our parameters. Parameters for A, parameters for B. For parameters in terms of A, we need to find the velocity of A and acceleration of A in terms of RA. And the direction must always be in accordance to RA. And the direction for B is the same thing as A. You need to be in accordance to RB. Why is it so? Because we find out VB, VA, AB, AA all by directly differentiating from the previous term. So if you differentiate it directly from the previous term, you keep the angle, but you change the magnitude. Because this is literally what you do when you were to implement it with the constraint equation. In order to make the equation that is formed from these parameters to be exactly equal to these equations, to this term used in this equation to form the constraint equation, I need to make sure that they represent the same direction. Since you get the velocity and acceleration term by directly differentiating the previous term, the velocity and acceleration term here must be also obtained by directly differentiating the previous term, and hence the direction must be kept. Okay, so in this case, I managed to get this equation. When I do the simultaneous equation, I can just get what I need. Alright, so for this part, if you are still a bit unsure, please kind of WhatsApp me. But I will show more questions here when it comes, okay? Thank you.